Okay, so section 1.4b, linear systems in 3 variables. We're going to up the number of equations. Instead of 2 equations, we're going to have 3, and we're going to up the number of variables. Instead of 2 variables, we're going to have 3. So instead of xy, we're going to have xyz. Okay. Your first example, I'm going to start you off with an easy one. Okay. Eventually, all your problems will turn into something as simple and easy as this. But on our next example, we're going to have to do a lot of algebra to get here. But I'm confident, given this linear system of 3 equations and 3 variables, everybody in the room would say, I could probably solve this. So it starts off with x equals 3, x plus 2y equals 5, and negative 2x plus 3y minus 4z equals 1. So what's helpful here? Damon?
X equals 3.
X equals 3. You can do what with that? Substitute it into both equations. It's going to be really helpful in the second equation, right? If we substitute 3 in for x in the second equation, we'll get 3 plus 2y is equal to 5. And then we have only one variable, y, which we can solve for. Subtract 3 from both sides. 2y is equal to 2. Divide by 2, so y is equal to 1. If I know y is equal to 1 and x is equal to 3, am I able to solve for z here? Yeah, I have one equation that has all 3 variables in it, so I'll plug in the 2 variables that I know, and I'll be able to solve for z. So I'll do something like negative 2 times 3 plus 3 times 1 minus 4z equals 1. Do my multiplication to get negative 6 plus 3 minus 4z equals 1. Negative 6 plus 3 combines to make negative 3. And I now have a 2-step equation. I've got to add 3 to the other side and then divide by negative 4. So z is equal to negative 1. Instead of writing our answers as x, y ordered pairs, we're going to write our answers as x, y, z ordered triples, because it will have 3 values. So we'll have something like 3, 1, negative 1 as our x, y, z ordered triple. Ordered triples exist in 3-dimensional space. So like the xy coordinate plane that you guys are used to working with is flat. It's on your paper. And it only goes in 2 dimensions. If I add a z term, I'm adding the 3rd dimension, which gives us a space. We really won't be plotting our answers, so we don't have to worry too much about the 3-dimensional space, but just so you know, it does apply to 3-dimension. Any questions about that example that I could answer for you? Are we all pretty comfortable with that, Faith?
It's a little different, but it's substitution and elimination the only 2.
Okay, the question is substitution and elimination the only 2 methods to solve? those are the two algebraic methods that you learned in Algebra 1. You have another method, which is graphing. So if you would graph those two equations, you could see where the lines intersect, and then their intersection would be a solution. You could also use guess and check, guessing x values and y values until you find two that work for x and y. That's probably not the most efficient solution method because there could be a lot of options for x and y, right? And what if they're not even integers in the end? Then you'd be in a kind of a bad place. There's also some other mathematical methods using matrices, which you guys haven't studied. If you take Algebra 3, you might get into matrices. But you can solve systems using matrices and things like Cramer's rule and determinants, but you guys don't have those skills right now. So there's actually a lot of methods to solve systems, but substitution and elimination are the two from Algebra 1 that are algebraic methods. Good question. Anything else? Okay, I want you to remember how nice this was, okay, and how smooth this worked. Once we knew one of them, we could solve for all of them. And how long do you think that took us? 2 minutes? 2 to 3 minutes? Okay, so eventually it will get down to that. Let us do a problem where we have to do some grunt work in the beginning. So write these equations down. Okay, this is a 3-variable system, 3 equations, and I'm not going to tell you what x, y, or z is right off the bat. So a little bit less nice. We have x plus 2y minus 3z equals 11. 2x plus y minus 2z equals 9. 4x plus 3y plus z equals 16. Okay, so that's a lot of equations to keep track of. We're going to keep this real organized so we can have conversations and communicate with each other about what equations we're talking about. So what we're going to do at the very beginning of our 3-variable system is label our equations A, B, and C. So I'm just going to label them A, B, and C. Now, 3 variables is too many. We don't have a method for solving 3 variables at a time. But we do have the methods, like Faith asked about, of 2-variable solutions, substitution or elimination. I'm going to lean very heavily on elimination today because they'll be set up for elimination. Okay. What you are going to do is you're going to pick one of the variables in the system to eliminate, and you're going to eliminate it twice. We'll do 2 separate times eliminating the same variable. This is Ms. Conkey. Yes? Yes? Sure. Stephen and Faith, could you run to Mr. Bell's office? Okay. We're going to eliminate one variable 2 times so that we create 2 equations that have 2 variables like we know from Algebra 1. So the big question in the beginning is, which variable do you want to eliminate? X, Y, or Z? Look over your equations. Does one variable seem better than the others to anyone? Jackson, you're saying yes. What do you think? X. Kylie, you were going to say X. Why do you guys want to eliminate X? Okay, so we could get the coefficients to be the same, or opposites, I suppose, a -2 and -4, so that we could cancel them. So I'm okay with that. Let's eliminate X. I'm going to write that down. We're going to make sure that we're eliminating X. And you need to pick only 2 equations at a time. So like we could choose A and B. We're going to eliminate X in equation A and equation B, but it won't eliminate as it is. What will we have to do to equation A to make x eliminate? Multiply by -2. So I'm going to write that down. This is how we'll communicate to each other what we're doing to solve our system. We're going to multiply the very first equation A by -2. And then I can come up here to my equation A, and I can go ahead and multiply everything by -2. So I'll get -2x minus 4y minus 6z. And don't forget to distribute on the other side, equals -22. Everybody okay where I got those numbers?
Why did you get BZ?
Oh, that's a 6.
Could you be negative?
Oh, it should be positive. Thank you, Lauren. I missed my negative there. Am I okay otherwise? Thank you for taking care of me. We would be so sad if I did not fix that right now. So sad later on. Okay, but B, we can leave it as it is, right? So we'll just copy that one down. 2x plus y minus 2z equals 9. And then we're ready to stack and add. Now, when you're adding down, make sure you do the thing that you said you were going to do. So we said we were going to eliminate x. And we actually eliminate x. So that's a good thing. Okay. Keep adding down. I should get -3y plus 4z. And then -22 plus 9 is -13. And I'm going to call this equation D. It's a new equation with 2 variables. So we picked a variable to eliminate x. We eliminated it once with equation A and B, and now we're going to eliminate it twice. What equations do you guys want to use this time? Can't pick A and B again. Jace?
B and C.
Okay, we could choose B and C. Could you choose A and C? Sure, you could use A and C if you wanted to, but we'll do B and C. That's not a problem. And they won't eliminate as is. What will we have to do to equation B? Just multiply by -2 again. So we'll do that again. I'll get -4x minus 2y plus 4z equals -18. Copy my c, which is 4x plus 3y plus z equals 16. Stack and add. Again, make sure you do the thing you said you were going to do. So we said we were going to eliminate x, and we eliminate x. We'll get positive y plus 5z equals -2, and we'll call this equation E. Did anybody find any mistakes I may have made? Okay, so we're doing a lot of algebra, right? What we have just done with D and E is we have created a new system. This is like a 2-variable system from Algebra 1. So I'm just going to write it over here on the side. Here's my D and my E. I have -3y plus 4z equals -13. And y plus 5z equals -2. So if you think about what we did yesterday with systems of equations in 2 variables, we can all solve this system. Okay. So this system with just the two variables and the two equations is probably set up best for elimination. Will either variable eliminate right away? No. Riley? Multiply E by 3. Okay, so we're going to take D and E times 3. And we'll eliminate our y. So we'll have negative 3y plus 4z equals negative 13. 3y plus 15z equals negative 6. Did I multiply correctly? Now I'm nervous. I might make another mistake. Stack and add. This times my y will cancel. I'll have 19z equals negative 19. So z must be negative 1.
Your sixes look so much
I
like
know.
these.
I don't know why they do today. This is a 6. Does that make it look better? I apologize. I'm going to work on that, okay? Make them look more like 6s. Okay, so remember how on the last example we thought that one was super easy? We're at that point. We have one solved. So we know z is equal to negative 1. It'll take us maybe 2 more minutes to solve for y and x, just by substitution.
Is every single one of our homework questions going to be this long?
No. No. I'm not that cruel. There are a couple that are like our first example, and then there are a couple, I think maybe max 3, that are like this. So we've got z equals negative 1. We can solve for y really easily by plugging into either equation D or E. I'm going to choose to plug into E. Okay. So I'm going to say plug z equals negative 1 into equation E. So I get y plus 5 times negative 1 equals negative 2. That looks like a negative y, but it's just regular y. And that's y minus 5 equals negative 2. So add 5 to both sides and we have y equals 3. Okay, so that wasn't bad. And then take y equals 3, z equals negative 1, and plug it back into one of the original equations. Does it matter which one you plug it into?
With the original or one?
One of A, B, or C.
Then why did you do y into e?
Well, so when you first solve for z, you'll plug it back into either D or E, because then you'll plug it in for Z and you'll have only Y to find. But we can't plug it back. If we plug Y and Z back into these, we'll never find X, because they don't have X. So now that we have 2 answers, we want to go back up to A, B, and C, plug in to find X. So we're going to plug y equals 3 and z equals negative 1 into, do you want to plug it into A, B, or C? A. I like plugging it into A because x is all by itself. So once I move those to the other side, I'll have what x is. So I'm going to say x plus 2 times 3 minus 3 times negative 1 equals 11. That's x plus 6 plus 3 equals 11. combining my like terms, x plus 9 equals 11. So x must be 2. So it's strictly substitution and solving for a variable. So my ordered triple answer is 2, 3, and -1. Whew. That is a lot of work. The best thing I can say in preparation for doing those problems on your own is in the very beginning, be very organized and be very certain about what you're doing. I'm choosing to eliminate x. I will do that 2 times. I will have a new system. I will solve that like yesterday. Then I can roll through substituting in my different values. Okay. The last thing that I want to do is have you just jot down in words basically what we're doing in these problems. So sometimes you look back at your notes and your algebra just looks like a jumbled mess of numbers and letters mixed together. Here's what I would offer up as like, this is basically the process we're doing. We're going to rewrite 2 of the original equations at a time so that they'll be in 2 variables. And we have to choose 1 variable to eliminate, and we have to eliminate it twice. That was at the very beginning when you guys chose x. Okay. If you look at your 3 equations, sometimes 1 variable is easier than others to eliminate. So you can choose to work smarter and not harder. Once you've rewritten and you have 2 equations with 2 variables, you can solve that system. You'll be tired. You'll be possibly not wanting to do more algebra, but you can do it. Okay? Give yourself the space and the time that you need to do that. After you solve the 2 variable system, you'll have 3 of the variables, so you can substitute, you'll have 2 of the 3 variables, so you can substitute those in and solve for the final variable. You'll go back up to one of your original equations in step 3. So you'll choose equation A, equation B, or equation C. The last thing to note is that the same thing can happen in 3 variable systems that happens in 2 variable systems in terms of if you have no solution or infinitely many solution. Now you won't have any of these on your homework tonight, so don't worry about this for your homework. It shouldn't happen, but it's at least good to mention that this is a possibility. Sometimes all your variables cancel out. You thought you were going to eliminate x and solve for y, but you eliminated everything. When that happens, all that's left over in your equation will be numbers. If your numbers make a false equation, like 0 equals 1, that's not true. 0 is not equal to 1. I would rather have $1 in my bank account than 0. Then there is no solution to the system. If all your variables cancel and you get a true equation, something like 0 equals 0, 1 equals 1, okay, something is equal to itself, then you know that all the lines were really the same line and you have infinitely many solutions. Okay, so what we would be talking about here is all the planes are really the same plane and we have infinitely many solutions. So it's a lot of work, but it can be done. We have to be patient and we have to be organized, but we're solving systems with 3 equations and 3 variables.